Hello, good morning, students. Hi, welcome to today's lesson. I hope you are wide awake and you're early and you are already in class. Okay, can someone please share with me whether you can hear me? Am I loud and clear? Okay, hi. Hello, girls. Hi, Stella. Hi, Crystal, Yun Chai Xuan. All right, okay, good. Are you able to hear me, girls? Can you please feedback to me? Okay, I see your names. All right, I will take attendance later. Okay. All right, good morning. Okay, Stella, yes, you can hear me. All right, okay, good. Okay, good morning, girls, everyone. Okay, good morning, Vivian. Good morning, Corsine. Okay, and Hui Hui. Okay, today I will share with you the lesson here is quite interesting because today we're going to learn how we actually produce electricity. Okay, you have learned in Form 2, I believe, that you have learned about the concepts of electricity. You've learned about current, voltage, and also resistance. Okay, these are the three things that go together when you talk about electricity. Okay, so today, now I'm going to share with you how we can generate electricity. Okay, how to make electricity, in other words. So this is interesting, right? Because we always use electricity every day, right? But we never give a second thought about how we actually make electricity and who discovered electricity. All right, okay. Now, first of all, let's look at this word. Okay, so I will start lesson now, yeah? All right, okay, good morning, everybody else. All right, yes, let's start this lesson. Let's not waste too much time. Okay, generation of electricity. Okay, 6.1. This is from your textbook. When you talk about generation, it actually has two meanings. When you have a generation, you think about one generation of humans or people from one family to another family to the next generation. That means the next generation will be the children, and the higher generation will be the grandparents. So that's called generation. But then generation has another meaning actually in English. Okay, generate is to actually make. So generation of electricity is to make electricity, or we say in Mandarin, okay, 发电. Okay, how do you make the electricity? So first of all, in order to make electricity, you need to have some sort of energy to produce electricity. So you need to have the sources. Okay, you cannot make something out of nothing. For example, if you want to make energy, we learn this. Actually, you're going to learn it later on. The energy is already there. It's just that it is existing. But energy can be changed from one form to another form. You cannot make energy out of nothing. The energy is already there, existing. Okay, but you can change the form of energy from one form to another form. We will see that in chapter 7, next chapter. All right, okay, so you have to, if you want to create electricity, you must make it from an existing energy source. Okay, so let's look at the existing energy sources. Okay, so there are many various energy sources to create electricity. So you've learned it earlier that there are actually two major groups. One is called renewable. Renewable means something that can be not finishing. The kind of energy resources is always there. It is renewable because you cannot finish it. It's always there. For example, sun, right? Sun is a renewable energy resource because sun will always be there. In fact, not to say forever lah. Actually, sun will also die. We will learn that later in chapter 9 and 10. Chapter 9, okay, that actually sun is there, right? But it only shines for a certain number of years lah. Okay, so do not worry, it's not a problem. Our sun will still be here for another at least 4 to 5 billion years. Okay, 4 to 5 billion years is a long time. So we can still say it is renewable lah, because it will take a long time for the sun to die actually. Okay, when the sun dies means it's no more, we are not going to get any more light, we're not going to get any more heat from it. So renewable energy resources are those energy which will not be so easily finished. Okay, will still be there. And non-renewable are those energy sources that actually will be used up, okay, very soon, and you will not find it anymore. Because actually, let's look at what examples first. Okay, look at here, energy resources or energy sources. You have renewable, you also have non-renewable. Okay, renewable energy sources, let's look at the definition. It is energy sources that can be replaced continuously or continually. It means it will always be replaced and will never deplete. Deplete means finish. So it doesn't finish. Reason is because there's a lot of it, and it can be again. It can be produced again and again. I mean, you cannot finish it, right? That's what it means by that. And for non-renewable energy sources, these are energies that cannot be replaced. So it's just the opposite. And will deplete, that means will finish. Okay, so look at the examples of energy that are renewable, okay, and also non-renewable. So renewable, like for example, hydro. Hydro is from the word like it means water. So water is always there on this earth. It's always on this earth because it is, and the amount of water that is on this earth is actually fixed. The water can change form from, let's say, from the rain, all right, when the rain drops to the ground, to our earth, then it flows into the river as liquid form. Then when the sun shines, it evaporates. When it evaporates, it goes up again to the air and it forms water vapor. And then you have cloud, it will drop again. So it's like a cycle. Okay. So the hydro, the water cycle, all right, you learned earlier in water cycle. So water will be converted from water into water vapor and back into water. So it's always there. Okay, so you see all the water in the ocean. You see the water in the lakes and the river. All right, you cannot really finish using it because if you don't see the water, it's actually in vapor form. But once it rains, it comes back down into liquid form. It's always there. Wave is the wave that we see in the ocean. Okay, it's from the currents and so on. The wave will always be there because of the movements of the ocean currents and so on. Okay, solar energy, this is the energy from the sun. So the sun will still be there for another 5 billion years. So no worries about it finishing. Okay, then tidal energy, this is the movement of the tides. Okay, high tide and low tide, also due to the movement of the earth and also the effect of moon. The effect of moon on the earth, you get the tides. Okay, high tide and low tide. 退潮 and then 涨. Okay, so it's like daytime you will have high tide. But at night time, all right, you notice that the water will run out into it's like the water level, right? Between at the beach, when you're at the beach at night, when you go up to the beach at night, you find that the sea is very far away. Because the reason is because the tide is low tide. The water has like run away, to the middle of the ocean there. Okay, that is called the tide. Then you have wind energy, right? Wind energy is actually, wind is moving air. So when you have a place where it's high pressure, okay, air pressure, and we have another place of low air pressure, so the air will move from high pressure to low pressure. And when it moves there, you have the wind. Okay, so wind happens is because you have two places where you have different pressure of air. Okay, biomass. Okay, biomass I'll explain again afterwards. I'll explain later because I'll show you another diagram. Then geothermal. Okay, this is the energy that we get from the water which is under high pressure inside the earth. Okay, especially when you go to New Zealand. New Zealand, you have a lot of these geysers and geothermal, we call it areas where the water underground is being heated. It's heated by the rocks and so on. It's very hot. And then once they find there's a place for it to escape, so the steam will come out. So you can use that steam to generate electricity. So even if you look at Ipoh, Tambun here, you have these hot water springs, right? A lot of places you have hot water springs, right, in the whole wide world. So Tambun in Ipoh here is another place. So when you have water heated up, you find that the energy, when the water becomes hot, right? And if you trap it under high pressure, you will find that they will get this geothermal energy. Sometimes it even bursts out from the ground. Okay, we call it geyser. Geyser is hot water and steam being ejected out because of high pressure. You can use that as a form to produce your electricity. Okay, after this, now let's look at the non-renewable first. These are examples of non-renewable energies. Okay, because we call it the amount is fixed. Okay, even though you say you can produce new ones, But because we're using coal, natural gas, and petroleum at a very high rate, it needs millions of years before you can make coal, before you can make natural gas and petroleum. It's because of these animals and plants which are dead millions of years ago, thousands and millions of years ago, that when they die, the body will decompose, and they're buried underground. So when they're buried underground, you have layers and layers of sand and rock. So they actually convert this body, right, the tissues and everything to become your petroleum. From petroleum you get petrol, and you get diesel. That petrol, you go finish, you don't drive a car, right? When there's no more petrol, you go to the gas station and they pump in the petrol. So petrol and diesel come from petroleum. Natural gas is also produced from underground. Okay, all these dead animals, and the gas is used for burning. Okay, coal is from plants. Okay, trees that have died and buried underground for millions of years under high pressure and high temperature and high pressure, so they convert into become coal. Okay, nuclear energy is also from the ground. This is actually elements which are we call radioactive. So radioactive, they will produce this kind of rays which are harmful to the body. So we will see radioactivity in chapter 8. Okay, in Cantonese we call it phúc xạ. Phúc xạ is actually a phenomenon whereby these substances, actually elements, example is uranium, plutonium, okay, radium. They actually produce invisible rays which are able to penetrate into our body and actually change our DNA. So it's harmful. Okay, it's harmful, and some of them it cause cancer because the cells have already changed. Okay, so let's look at biomass now. Okay, biomass is an example of renewable. Okay, let's look at biomass. What is biomass? Okay, now biomass is a plant or animal material used for energy production. You can use the biomass to produce electricity or heat. Okay, now where do you get biomass energy? Okay, biomass comes from parts of the plant or animal, usually which are dead. Okay, so you have let's say plants from, let's say, the kitchen waste. Okay, kitchen waste is like fruit peel, 果皮, right, the fruit peel, or you take the vegetable, parts of the vegetable, the leaves and all that, they're already rotting away, right? You don't throw into the dustbin and all that, because you can actually convert them into biomass. So they can be, you get from where, right? They can be purposely grown energy crops, all right? Or wood or forest residue. Residue means the sisa. We call it the waste. Okay, waste from the food crops like wheat grass. Like for example, we plant this corn and all that. We cannot eat the husk, isn't it? Husk is actually the cover, the peel that this is the corn. Let's say this is the corn, right? Now that the thing that you have to peel off, all right, this one, this is called the husk. You can use that to if we call it it will decompose, all right, and then you can get energy from that. That is biomass energy. So this is corn husk, all right. It can be from animals. For example, manure is actually the waste. We call it the feces. Okay, very crudely we say shit lah. Okay, we don't say shit, we say feces. So manure is in Mandarin you say the 大便. 大便 is the the shit lah, right? Okay, and also the you call the urine as well. All right. So manure, they are rich in nitrogen and phosphorus. So when you convert that manure, you can actually get baja. Okay, get fertilizer. Okay. We can also use the biomass to be converted to get a kind of gas. Now this gas is called methane. Methane is combustible or is flammable. It can burn. So from all these manure and the parts of the plant, all right, that is rotting away and all that, we can actually convert them into energy. Okay, so biomass, the meaning, okay, is organic. You can see this word organic. A lot of people like to use this word organic, right? But do you know what it actually means? Organic, it means when you say something is organic, for example, I buy organic food, or the person, that farmer carries out organic farming. What does that mean? Organic means it comes from or made from living organism. That thing is coming from living organism. For example, when I say I'm using organic fertilizer, that means I am not using man-made fertilizer. Fertilizer that humans make, I mean man-made, that means it's not outside their body. When I say I'm using organic fertilizer, I'm using things like the waste from the animal. Okay, the animal, the 大便, right? The animals, the urine, because the feces and the urine come from the body of the animal. The animal makes it, or even human makes it. All right, comes from the body. That's come from the living organism. Okay, so it also can mean parts of the plant, the skin, not the skin, you call it the epidermis, all right, the fruit, the skin, all right, and also the parts of the plant or the human body and all that. It's actually living. Okay, but of course it comes from human body lah, right? So it is used for usually common biomass material are the plants, the wood, and the waste. So we normally use the waste. So in India, if you have biomass, they don't normally use the cow dung or the feces from the cow. Okay, the 牛大便, right? Because there's a lot of there are a lot of cows there in India, and they are considered sacred. Okay, sacred means you're not supposed to eat the cow and all that, right? So they cannot eat it. So they actually use a lot of that, the feces, and convert into biomass energy. Okay, so biomass is considered a non-renewable energy mass because as long as you have humans, as long as you have animals, as long as you have plants on this earth, it will never finish because you always get parts and waste from them. Okay, so this methane is the gas that is produced once this biomass undergoes decomposition. This gas can be burned. In fact, this gas is also what we get from our fart. Fart, right? When we fart, right, actually if you're able to collect all this fart, actually this kind of gas from there contains methane. And this, as a methane, if you were to light up your fart, actually can explode. Okay, this is a knowledge for you. So methane is flammable, it can burn. Okay, now that we've done the definition of biomass. Okay, now we look at all these pictures here. These are examples of power station. So what is a power station? A power station is a place where you make electricity. Okay, we make electricity on large scale because you have so many humans in Malaysia here. You need a lot of people, need a lot of energy, right? Because it's so simple nowadays. You just switch on the switch, you can get your light, you can get your lamp, you can get your fan, your washing machine, your refrigerator. So simple. How do you make this electricity on large scale? Every family needs electricity to run their electrical appliances, correct? So you need to you need to have something, a place where you produce electricity. This is called power station. Okay, so in a power station, you will have at least one important device called a generator. You will see that later, what a generator is and what's inside a generator. So if you look at this picture here, this is a hybrid power station in Pulau Perhentian in Terengganu. Now, what is the meaning of hybrid? Whenever you see this word hybrid, it means it's a combination of more than one thing. A hybrid is like a mix, a fusion between two things. Okay, what do they fuse inside there? So you will see here, they use, all right, this wind turbine. Wind turbine is a very large contraption where when the wind blows, the fans will turn. Okay, so when the fan turns, it actually turns a generator. So it's connected to a generator inside here. Now, either here, I'm not too sure, here or in the ground. So when that thing spins, the blade spins, the generator will also spin. So when the generator spins, that is the thing that gives you electricity. So afterwards, we will see how it makes electricity. What's inside the generator? Okay, so they make use of wind energy. It also makes use of this. You see all these solar panels. So it also uses solar energy. So that means it's more than one. When it's more than one, we call it hybrid. Okay, even though whenever you see the word hybrid, for example, we have a hybrid car. What's a hybrid car? Hybrid car are usually more expensive because they combine the power from, of course, they use petrol. Right, you have to go to the petrol station to pump in your petrol. And not only because of petrol, they also use electricity. That means it's more or less of an electric car, but not 100%. A hybrid car will use electricity and also use what we call petrol. So it is more energy saving because you do not need to use so much petrol. It also relies on electricity. Okay, so that's called what we call a hybrid car. Whenever you see the word hybrid, it means it's a combination. It's not pure. A hybrid is not pure. It already combined. Okay, and also it has another thing, diesel. So it has another thing more than one. It has three here. It also uses diesel to produce electricity. Okay, so this is one type. Okay, then you can see next is other examples. This is a hydroelectric power station which we have in Bakun in Sarawak. Okay, even in Perak there is this Empangan Temenggo. Okay, Empangan Kenyir. Sorry, Perak is Empangan Kenyir. All right, you have the water being dammed up in a dam or lake, and then we force the water to pass through the dam. Hydroelectric power station. And it turns the turbine inside there, it will produce electricity. Okay, and when we look at it, the next lesson, so this is a very general idea. What is a power station? What kind of energy they use? So this one uses water because it's hydroelectric, right? So they uses water to generate electricity. So here, this one, look at this Tuanku Jaafar power station in Negeri Sembilan. Okay, so they use natural gas. So natural gas, that means it's all the gas that you get when you get your petroleum. This one, you see there is a lot of pollution. Whenever you use non-renewable, natural gas is here, non-renewable, you see, right? Except for nuclear, nuclear you don't, okay, these are called fossil fuels. Whenever you use fossil fuel to produce energy, you have to burn them. There's no other chance to release. There's no other way of releasing the energy inside the coal, the natural gas, or petroleum. You have to burn it. Okay? So when you burn it, the disadvantage is you will get pollution. So you see the gas, mostly carbon dioxide, okay, and other gases as well. So all these will produce what? Pollution. Actually, because it's not pollutant, but it will produce what they call increase the greenhouse effect. Okay, greenhouse effect, not the greenhouse. It's not good, not to say greenhouse is good, because the greenhouse effect means the earth will become warmer. It causes global warming because carbon dioxide has been known to trap heat. So the heat will be trapped more and more on this earth, and it does not allow the heat to be radiated back to the space. So when you have more and more carbon dioxide, it causes greenhouse effect, and that in turn causes global warming. Okay, and then pollution not come from carbon dioxide. The pollution comes from other gases, for example, nitrogen dioxide, SO2, sulfur dioxide that we learned earlier in the respiration chapter. That one will produce, of course, harmful effects for our lungs and so on. Okay, you can also see the soot. Soot is the black thing that you see here. Okay, so that will pollute the environment. So whatever you burn actually is going to increase pollution. All right. So using coal, all right, here's another one. Using coal, this is the coal power station. So this is a natural gas power station. So different types of power station, depending on what kind of energy source they use. Do they use water? Do they use diesel? Do they use solar or wind or what? These are the sources for different power station. Okay, so different types of power station will use different sources. So this one is another one. You see, when you burn something, you will get a lot of smoke. Okay, so this is again not good. It's because it is non-renewable. Another thing is it is producing a lot of smoke. Okay. So here, diesel also you have to burn because this is a non-renewable energy resource. So go power station. So you burn it first. You have to burn the diesel, and then only get the power from it to turn other things, maybe to turn the generator to produce electricity. Okay, that means you're converting from your coal, from your diesel, from your biomass, whatever energy that's inside there, into electricity. That is actually a conversion of energy. When you make electricity, you're actually converting the existing energy into another form, which is electricity. Okay, so here's the last one. One example here will be biomass. So this biomass uses, I do not know the source, maybe uses parts of the plant or animal that is dead or whatever, or maybe the feces or the manure from animals or plants, animals, okay? So let's look at the process of generation. How do you make electricity? Yeah, this is a very interesting topic, right? Electricity is so useful to us in our modern society. You cannot imagine sometimes when you have the DNB, the notification tell you, okay, 停电, okay, stop electricity for, let's say, half a day. You find it so uncomfortable already, isn't it? You find such a hassle. You cannot switch on your TV. You can't even charge your phone. Okay, you cannot do so many things. You can't switch on your desktop computer. You can't wash your clothes by your machine. You can't switch on your refrigerator. The food will go bad if the time is too long, right? So it's so uncomfortable to imagine even half a day without electricity. So where does this electricity come from? Okay, now how do you make electricity? You need a device called a generator. Okay, it's a device that you use to make electricity, a generator. The 发电机, all right? It is a thing that human invented to make electricity. So in a simple way, actually you've seen this word dynamo. Dynamo, you have it on your bicycle. Now, how do you get your bicycle light to work? It doesn't have electricity. It doesn't have a power bank, isn't it? But when you cycle your bicycle, I don't know when you have old bicycle, right? The bicycle, when you cycle it, and then your dynamo is connected to the wheel. When the wheel turns, the dynamo also will turn, right? The parts inside the dynamo, and then you will find there is electricity. Your lamp will light up. So dynamo is similar to a generator. It's like a simple generator lah. Okay, you actually can use it also same meaning. So what is inside a generator? What makes it able to produce electricity? Okay, let's look at the interesting part. Now we're going to learn how to produce electricity. Okay, so first of all, you need two main components, two important parts. Without these two parts, you cannot make electricity. So what are the two parts? Okay, so number one here, you need a pair of magnets. A pair, why do I say a pair? Because a magnet, you must have north and south poles. Okay, a magnet, if you just use north only, it's not useful because you do not have the magnetic field lines. Okay, when you have a north and a south, okay, let me show you. Now, you've learned this before, right? When you have a north and south, the magnetic field lines exist between the two poles here. So a north, you see that if you draw the magnetic field lines, 有一个磁场，那个磁场的线啊, right? The lines is invisible, you cannot see it, but it's there. It doesn't mean what you cannot see is not there. Okay, so if you draw the magnetic field lines, it always go from north to south. Okay, north to south, and the direction of the lines actually is, you must draw arrow to show it's always from north to south. So these are the invisible magnetic field lines, all right, that you have between the north and south poles. Of course, here is also south lah, all right. Here is north lah. You also have it over here, all right, but it's much weaker lah because it's so far away. Okay, I shouldn't draw so near. Okay, so it'll be much weaker, right? Much weaker, the lines will be further. And then you see, you learn all this before, right? In from what? Form 2, I believe. You learn about magnets. Okay, so here also got north to south, north to south. Okay, north to south. And it's a revision also. Revise your form. Sorry, it's very difficult to draw. Very smooth. Okay, here. So here will be north. The lines will be coming up from north. The lines always come up from north, and they always enter the south. So this is something that you must remember when you want to draw magnetic lines. So these are magnetic field lines between the two poles of north and south. Now, that's one thing. First thing. Second thing is, besides your magnets, you also need a coil of wire. In fact, you don't need coil. In fact, just to be basic, you just need a wire. Okay, wire is important. Now, wire. Right. Now, why do we need coil? What is a coil? A coil is like this. Instead of having just one wire, instead of having one wire like this, what we do is we coil it. So we coil it means we coil like this many times. We curl it up like that. Okay, the wire is actually very long. So when you curl it up, then you get a coil. Okay, so for example, right, show you, this is a wire, right? When you want to coil it, okay, let me show you with this I show you. All right, like this. Okay, show you like this. So you have, this is wire, let's say lah. It's not a real wire lah. It's actually my webcam wire. Okay, so this is wire lah. You just need a wire. But why we need a coil? Because with one wire, you find that when you want to generate electricity, it is not very effective. The current that is produced is going to be very low. So in order to increase that, so in order to increase that, so what you need is actually you need a coil. So how to make a coil? Very simple. You take a wire, right? And then you go it around and around, and you normally curl it around a core. We call it a wooden core or something, right? You curl it around wooden, the one metal, then you get a coil. So this is called a coil. Okay, can you see? This is a coil. A coil, it consists of a wire going around itself many rounds. This is a coil, right? So it's not very neat, because I didn't do it properly. Okay, so I'll do it again. This is a coil. This is a coil. All right, you coil it around a core. There, you get it. Right, this is a coil. Coil. Okay, so if you use a coil, it is more effective in producing electricity because it's more current, because the way you later on we see how we cut it. How do we get electricity? You will do something. All right, let me check here. All right, so how do you make it? How do you make electricity? First, you need magnets, a pair of magnets, and then you need to have a coil of wire. Now, where you place this coil of wire? This coil wire must be in between the north and south. So you can see the picture is a bit fuzzy here. All right, this is let's say north, and this is south. I mean, red color normally is south. So the blue one is north, and the coil is in between. So why do we put in between? Because you need the wire to cut. Let's say here, so you have your magnetic field line, right? This is your north and south. Let's say I want to use the wire to cut the magnetic field line. So I cut. So when I put my wire in between, okay, so let's say, for example, these two are the magnets. Okay, I'll show you again. Right here, I'll just besarkan a bit. Okay, so here you have, okay, so here you have, let's say, two magnets, right? One is north, one is south. And what you need to do is there's magnetic field in between, which is invisible, right? You can't see it. Then what you need to do is, let's say this is a wire. The wire has to cut. So how to cut it? Right? You put it there, it's not cutting actually. It's stationary. Stationary means it's not moving. When it's not moving, you're not actually cutting it, because you when you want to cut something, let's say imagine you're using a knife. In order to cut, you got to move it, isn't it? How do you cut something by holding the knife? You cannot cut something by holding the knife. Let's say this is the knife. Right? It's not cutting. When you want to cut, you got to move it up and down. You got to move it up and down. That only you cut, isn't it? And it makes a lot of sense. When you're holding a knife, you got to move it up and down. When you're holding the knife only, it's not cutting. So you got to cut it. So the third thing you need, besides your number one magnet, number two is your wire, you also need motion. You need to move your wire up and down. Okay? By doing that, this wire, imagine this pen is a wire, it is actually cutting the magnetic field lines. When that happens, actually you have produced electricity. Okay, when you cut the magnetic field lines, actually you're producing electricity. This is the basic concept you need to remember. Okay, so it's something like so simple, just cut a magnetic field lines, okay? Then actually it produces electricity. Now this concept is actually discovered by Michael. So this person, all right, you need to have two devices, and don't forget you need to move your wire inside. So you need to have motion. Motion is pergerakan. You need to cut it. When you cut it, then you have already produced electricity. Okay, so this is called induced current. Induced current means the current that is produced by this way. This you make the current that is made. This is called induced current. And if you were to connect to an light, okay, how do you turn this coil of wire? You use a crank. What's a crank? Crank is something that, you turn one. You use something, after I show you, there's a device here, you turn it and it will produce electricity. So this, when you connect to an LED, actually the LED will light up. And when the LED lights up, it shows that there is electricity produced. Okay, I'll show you something which I have. Okay, now this is actually a hand-powered torchlight. I show you here. Wait, I will just make it a little bit bigger for you so you can see better. Here. This is actually I bought from IKEA. Right? Now it is actually a torchlight. But torchlight, as you know, all of them needs what? Needs battery, right? This one doesn't work on battery. On the other hand, you have something that you put your hand in and then you turn. This is called a crank. All right, now, so I want to show you how it works. Now you see the light is not lighted, right? Okay, so when I turn this, okay, hold on. It's going to be a bit loud. It produces sound as well. Wait, I haven't switched on yet. Okay. Sorry. Now, the light doesn't turn, all right? Now, but I turn, you see when I turn it, what happens? You can see the light produce. You can see that it works, right? Now, when I stop, okay, now why when I stop, it still lights? Because it has a capacitor. Inside it stores a little bit of charges. Okay, but if I don't have the capacitor, when I stop moving this, when I stop moving the crank, it's no longer, so inside there must be a coil of wire, and there must be magnets here because it's cutting the magnetic field lines. When it cuts the magnetic field line, it will produce electricity. Okay, this is a very simple. I cannot show you inside because I don't have a proper generator to show you the inside. We at the school we have. Okay, you can go back to school. We can show you that. But I can't open this up. I don't know where to open this. Okay, so this is a device that is ready made already for people to use it as a torchlight. Okay, to produce electricity. Understand? Right? So you need to have what? Let's revise. You need to have very importantly the power wire, coil of wire, and you also need to have magnets. The stronger the magnet, the better. The stronger the magnet, you will get a better, higher current. Okay, and also the more wires you coil, the stronger your electricity will be. Okay, the current. That's why we don't use just one. When you use one and just move it up and down, you hardly can see anything. Especially if you use LED, it's not going to light up. Okay, because the electricity that is produced is very little. It's not strong enough to light up your LED. Okay, so in other words, let's say if the electricity is not strong enough, you can still show there's electricity. What you need is a device called galvanometer. Okay, galvanometer can be used to detect or to show to make sure or to sense if there's very little electricity. So you see, measure minute, not minute, minute amounts of current. You call it small amounts of current. You can use a galvanometer. So you don't necessarily need LED. When you connect your LED, if your current is not strong enough, you may not even see the lighted up. I mean the LED light up. What you need is a galvanometer. Very little current. You see the needle of the galvanometer, we call it the pointer, will be deflected. Deflected means it goes left and right. Okay, so when you move it once, let's say the wire moves down, you get it, let's say go to positive. When you move it up, it goes negative. So the thing will be moving here like this, left, right, left, right, left, right, left, right. Okay, when the needle is deflected, it shows that current is generated. You will have electricity. So what you need to do is when you want to show, you want to do, you don't want to carry out this experiment, you want to produce induced current, your wire, now this purple thing is the wire, all right? You do, what do you call that? This one, okay? This is the movement, up, down, up, down. Your wire has to move between your two magnets, up, down, like that. Okay, and then when you go down, you will move the deflector, the needle, the pointer will move one way. When you move it up, it goes the other way. So it will be deflected. It will be deflected. Deflected means it's not in the middle. The middle is zero. Left, right, positive, negative, positive, negative. Okay, you move it one way is positive, you move the other way, you get negative. So let's look at this one. Now, his name is Faraday, all right? So he produced he did investigations, right, on generation of electricity using a magnetic field. He found that he could produce current by this method. What method is it? You need to cut the magnetic field lines. So how to cut it? There are two ways. Number one, move the wire. When you move the wire, that means your magnet don't move. You cannot do two things together. When two things moving together, the movement will be relative to each other. They will be considered still static. They're considered still not moving. So you must move. One thing move, the other thing don't move. Okay, let's say this is your U-shaped magnet, and then this is your This is the wire. So you make your you want to move your wire, your magnet must be stationary. Okay, so the first one, movement of wire which causes the magnetic field lines to be cut. So you move this up and down, right? Move it up and down. You can see the galvanometer, the pointer will be deflected. It goes left, right when you go up and down. But once you stop moving it, when your wire is stationary inside there, it will go back to zero. Okay, because you're not cutting it anymore. If you stop the movement, you're not cutting. Just like you're taking a knife, right? You're just holding it in it. You're not cutting it. You got to move up and down to cut things, right? So a connecting wire, solenoid. Now this is a connecting wire, just singular, just one wire. One wire you can produce. Like I said, it's very, very little. You probably have done it before in school. It doesn't work. You're very, very not easy to get any movement on the galvanometer. But you want to make it easier, right? You want to make the electricity a little bit stronger. What you can do is make a solenoid. What's a solenoid? A solenoid is actually a coil of wire. So you get a long wire and then you coil it around it, then you get a tube, something like that. All right, you can coil it around a paper, the toilet paper roll there. All right, you can get a tube. We call it a solenoid. It's a coil in cylindrical shape. It's called solenoid. Okay, cylindrical. So this kind of coiling. Then what you do is you move the magnet is stationary now, right? You move the coil, the solenoid up and down, up and down. You move it like this. Okay, you will also get the pointer of the galvanometer to be deflected. It will move, be deflected. Okay, another way, right? Another way is to do the opposite. You don't move the wire, but now you move the magnet. You see, movement of the magnet. All right, you can also do that. So now you put down the wire. Now you move your magnet. Also the same thing, because you will still be cutting the magnetic field lines, and you find the galvanometer needle will be deflected, and you will get induced current. Okay, induced current is produced. All right. Okay. Now, so another way, right? Of course, the same way, actually same way, but you want to intensify the current. What you do is you use a solenoid, all right? You use a solenoid. Again, the same thing. Now you don't move your solenoid, but you move the magnet. You move the magnet. Okay, the second method is moving the magnet. You will still get the same thing. The galvanometer, the pointer will be deflected. Okay, understand? So I see there's no questions here at the moment, right? So when the galvanometer shows that there is induced current. How do you know there's induced current? Because the galvanometer, the pointer in the galvanometer deflects. Deflects, you can say deflects or you say is deflected. Okay, either way. So let's look at some experiments in here. So this is an activity that we can do in school if we go back to school, right? So first of all, you see, there are four things to do, right? Four different things to do. Step 2 here. First of all, you got to connect. You got to connect the wire to the galvanometer, right? You set up like this. And then now what you need to do is you move the copper wire, number 2. Step 2 is you move the downwards between the north and south pole and then upwards. Okay, so you do it continuously and then observe and record the observation. Right, so number 2 is here. Okay, I want you to think what over here. Okay, I just explained the experiment first. Then number 3, move the U-shaped magnet. Now number 3 is this one. So now this is number 2 just now. Now step number 3 is the opposite. You put the wire down, don't hold the wire, but now you move the magnet. Okay, what is going to be observed? That is number 3. Okay, number 4 now. Okay, then I go to straight number 5. Now number 5, you do the opposite. You move the coil of wire. So this is number 5. Okay. Number 5 here. Now you're using not just wire, you're using coil, which is called a solenoid, a coil of wires. Now you move the solenoid. Magnet, stationary. Stationary means not moving, right? They move it up and down. What happens? Observe, observation. Observation is very simple. You just see, you just write down what you see. No need to give explanation. When you give explanation, it's called inference already. Observation is what you see, what you hear, what you get from when you do the experiment. Okay, observation, right? You can be, let's say color change is observation, sound is heard, okay? Or you can see something moving, okay, like the needle here, the pointer or the pointer of the galvanometer. That is called observation. But don't give reason, because the reason is you save it for the next question. Usually it's asked you, it gives the inference. Inference means the reason for your observation. Okay, so a lot of students will ask me, teacher, what's the difference? What is the meaning of inference? So a very simple way to remember is inference is the reason for your observation. Okay, now, so the step number six here, same thing, you use a solenoid as well, but now you don't move your solenoid, but you move the magnet. Magnet is moved. Okay, so tell me, what should you write here? For all this deflection, don't talk about other things, you just want the deflection. Will there be deflection or no deflection? How do you write? There are many ways of writing this answer here. Okay, can I just have some response in your chat? Please try to give me some answer here. What are you going to write here? Deflection of galvanometer pointer. What are you going to write there? Okay, okay, so right, I'll just wait for a while. And look at now question 2 and question 1, 2, and 3 here. These are the questions that you should answer. Okay, wait, I got to. All right, so let's look at the answer here. I'm sorry, this is moved away. Yeah. Okay, can I have some response here? Is there anyone here who would like to tell me what are you going to write when you do this experiment? What are you going to get? What are you going to get? What is the observation here? Okay. Gigi, maybe we can get something from you. Yeah, what are you going to write? Okay, let me see. I got to respond. Okay, good. Let me see. The reading of the galvanometer. Okay, but if you put the reading, you got to say what is the reading. You got to say how many milliampere. That is called the reading. No need to write the reading. They just ask you the deflection. Deflection means will it move or not? That's what it says. Will it move or not? Deflection. They didn't ask you for reading. They didn't ask you how many milliampere. And by the way, the unit for galvanometer is milliampere because it is it detects minute. We call it small current. We call milli. So if normal ammeter, the unit is unit is ampere. Sorry, unit is ampere. But for galvanometer, the reading is milliampere. Ampere is MA. Okay, but we don't need that. We don't need the reading, right? This one, the question asks you what is the MA, milliampere. Okay, so the answer here, right? Okay, I will give you an idea what to write. Deflection of galvanometer pointer, right? Is there deflection or not? Just have to say that whether there is or there isn't. So you can put like okay, I just write in I just write in there. Okay, the pointer is deflected. Very simple. Deflected. D-E-F-L-E-C-T-E-D. The pointer is deflected. Yeah, okay, just say enough. Or the pointer deflects. Is deflected, or you just say deflects. That's all you need. That's all you need. So will it be the same case for number 2, 3, 4, and 5 and 6? Will it be the same? For the case number 2, because you're moving it, when you're moving it, you're actually cutting the what? Cutting the what? Cutting the magnetic field lines. So the most important thing is, are you cutting the magnetic field lines? If you are cutting the magnetic field lines, it means that you are actually producing a current. Okay, there will be current. This current is called induced current. Or you can just simply say electricity. Or you can just say electric current. Okay, now, so for number 3 will be the same. The pointer is deflected. The same, because you are actually cutting it. You can see the picture here. No matter whether you move the wire, whether you're moving the wire or you're moving the magnet, in both ways, because one is moving, one is not moving, it's actually cutting it. But when both of them are not moving and both of them are moving at the same time, right, that's not cutting. You have to have one stationary means not moving, and the other one is moving. Then you can see it cuts. Okay, let's imagine this is the U-shape, the U-shape magnet, and this is this one. It actually cuts. But if both are cutting, you see both are if both are moving, you see both are moving at the same thing. Where got cut? Both are moving like this. Moving is like same thing as stationary. 两个 both also like stationary. Then you got to do like this or do like this. Then only it cuts. For number 3 is the same. Number 5 is also the same. Number 6 is the same. You just need to write that it is deflected. Understand? All right. It's a simple. Yeah, you cut the magnetic field lines correct. Okay, now let's look at the answer question number 1. I give you a simple way already. Question number 1. You just need one word answer. What is detected by the galvanometer when the galvanometer points are? So when it deflects, what is the meaning? What is detected? The galvanometer already sends what to make it deflect? This is a simple question, I think. You try to put the answer there. Is detected by the galvanometer when the galvanometer pointer deflects. Okay, I'm waiting for your answer. All right. Okay, number 2. I'll check back the answer. What happens when a magnet moves relative to a copper wire or coil of copper wire? Okay, when one magnet moves and in relation to the copper wire, that means in relation means one moves, the other one doesn't move, right? One is the magnet is moving, and the copper wire is stationary. What happens? So I give you, you just fill in the blank on it. The magnetic field lines of the magnet are what by the wire? Okay, wire does what? The wire does what to the magnetic field lines? The magnetic field lines of the magnet are what by the wire? Number 3. What is produced by the cutting of the magnetic field lines by a copper wire or copper wire? So when you cut the magnetic field lines, what are you produced? What have you produced? So what is produced? Okay, so this simple 3 blanks. Okay, if you can, please type in what is your answer, 2, what is your answer, 3, what is your answer. I just take randomly just a few questions, a few answers from you. Okay. Okay, I see no answer yet. Come on. Yeah, please write down for this answer is for which question, because you have 3 here. I'll get confused. I do not know which one you're answering maybe. Okay, can you try to answer? It doesn't matter whether it's right or wrong. I want you to try. That's more important. Okay, more important is to try it. So number 1 is what is detected by the galvanometer when galvanometer pointer deflects? Okay, number 2, what happens when a magnet moves relative to a copper wire? So I've given you the answer here, part of the answer. The magnetic field lines of the magnet are what by the wire? Number 3, what is produced when you cut the magnetic field lines? Okay, now I've got the answer. Yeah. Okay, number 1, let's go to number 1 first. Yep, Xiao En. Okay, so your answer here is straight. Number then Stella, you say current. Okay, both of you are right. But actually, we call it electricity be better lah. Electricity, you can just put mainly electricity, or you can say electric current. Electric current. Electric current. Or what is another name for that? You can say induced. Yes, correct. Okay. Both of you are correct. Right? Induced current. Okay, now what about number 2? The magnetic field lines. What happens when the magnet moves relative to a copper wire? The magnetic field lines of the magnet are what? What is being done by the wire? What did the wire do to the magnetic field lines? In order to produce electricity, this copper wire must do something to the magnetic field lines. Okay, I see a question already. Answer already, sorry. So the magnetic field lines are cut by the wire. Yes, good. Cut the It's cut. Okay, you don't cut it, you're not going to get electricity. You have to cut it. You're going to move it. You're going to move it. You don't cut it, you cannot move. I mean, if you don't cut, you don't move it, you cannot cut. Okay. Number 3, what is produced? What is produced by the magnetic field lines when you cut it? Right? What do you produce? What do you produce? Cut is correct. Correct. Now let's go to number 3 now. What is produced when you cut the magnetic field lines? Okay. What is cut when you cut the magnetic field lines? Okay. It's not difficult. The answer, you've seen it. You've seen it before. I mean, it's similar to what you've already answered earlier. Okay, good. It is induced current. Induced current, you can use it. You can also say electricity. You're not wrong, Xiao Hui. Yes, induced current. All right. You can also say electricity. Not wrong. You can also say electric current. Electric current. Yeah, no, in other words, it's just electricity. Electric current. Okay, electric current. Okay, I hope this is clear to you. Yes, correct. All of you are correct. Huh? So it is simple enough to understand the concept. You just need to turn, or you call it, you have to cut it. And how to cut it? You use something to turn it lah. So here, I show you this thing. This thing here is a crank. So the next experiment here is showing something similar to that. This is a simple generator. Explain one more. The simple generator where you use your hand power. Very simple thing is you make electricity by your hand. Right? Your hand is actually energy from your body. So your movement here is called kinetic. Kinetic movement, kinetic energy, right? Conversion. And how do you get your energy? Is from your food that you eat. So chemical energy converted to kinetic energy. And then from there, it turns into electricity, electrical energy. Okay? If you have sound, you can see, you can hear the sound. You may also have production of sound actually. You can also hear sound. But not all generators will make that sound. Okay? Only my one is noisy. Okay, this one. Okay, let's go to the second one. Make a simple generator. Okay, a kind of simple generator is very simple. You just need very strong magnets. All right, look at here. A simple generator looks like this. Okay, my thumbnail for today's class, I use a simple generator. So you need north and south poles. Okay, so this is north pole this side, south pole this side, and in between there you need to have a coil of wire. Okay, there you see here, coil of wire which is connected to a commutator. Okay, listen, doesn't matter. It will just convert it into direct current. The commutator converts into direct current. That's all. You don't need to know how it works and all that. You just need to know there is magnet, strong magnets, and you need a coil of wire. And how do you turn it? Okay, you have an axle here. This is very similar to what I have for my device here. This one, right? This one. I have an axle here. So when I turn this crank, it turns the wire coil. It turns the wire coil. So this thing will spin. This thing, the what do you call this part? This whole thing. So it will spin just like. How did I show you that just now? This picture up here. This is the simple generator. Here. This one. So it will spin. So this one I just brought off first. Yeah. Okay, you see this one? You have invisible magnetic field lines. This one will spin like that. I don't want this color. Sorry. Okay. So you spin. This side will go down. This side will go up. Okay. This side will go down. This side will go up, and you will have. So one side go up, one side go down. So you'll be cutting the magnetic field lines continuously. When you continue turning it, it's keep on cutting. That's why you will see here. Right? Keep on cutting. But this one, when I stop, by right, it should stop. But this one will not stop because there's a capacitor that it will store the charges temporarily. Okay, so that's why it doesn't. It'll be very bothersome. You will keep on turning all the time, and then you cannot learn to hold properly your torchlight. Okay, so that's why it has a capacitor inside there. But to not only actually, you just need to turn it on it. Okay, so this is a simple generator. So we go back to this experiment here. This one, here. So make sure first thing you do is you make sure it's stationary. Stationary, that means it is not moving. Okay, first of all, condition of axle, stationary. Now stationary has got two meaning. One stationary is spelled with the E. One stationary is spelled with the A. All right, in English, both are pronounced the same way. When it's pronounced spelled with an A, it means not moving. Stationary is not moving. The other stationary is stationery. That one is all the alat tulis. We call it 文具, like pencil, ruler, eraser, your paper clip. All these are stationary things that you need for writing, things you need for studies. That is called stationary. But do not move it first and see the observe the LED light. What should you write over here? When it's not moving, will you see the LED? What is the observation for LED? Okay, now this one may be easier for you to write. The second one, now you do another time. Rotate, that means you turn it. Put your hand there and then you turn it. And turn. Right? Rotating is turning. Rotating means turning. What are you going to see there? Okay, after we check answers. Next one, now. Click true or false for the statements here. Tick for the true statements and mark the false. No, I didn't say false, but I want you to mark it false. So when the coil of wire and magnet are stationary, now look here, both are stationary. Coil of wire and also the magnet. Two things are stationary, the magnetic field lines are cut. Got cut. Okay, both are stationary, but already the magnetic field line is cut. So correct or wrong, true or false. Okay, that's A. Now for B, when the coil of wire moves inside the stationary magnet, that means this is a stationary magnet, right? When the coil of wire move means it's like turning, turning. The magnetic field lines are cut. They'll cut down, all right? So true or false. Number C, current will only be induced. That means there's only current when the magnetic field lines are cut. So when you cut the magnetic field lines, only then you will have current. True or false? Okay, so there are three simple questions here. Here, right? Okay, now after this, I'll transfer it over to this worksheet. Okay, number 2. How is induced current detected in this activity? How to detect it? How do you detect the current here? How do you know there's current here? Okay, how do you know there's current here? Next one. Next question, sorry. How is induced current produced by the DC generator? DC is direct current. How is it produced? I've given you a simple here, a simple sentence here. Induced current is produced when blah, 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 blah are cut. Okay. Number 4. State 2 forms of energy other than energy produced in this activity. Okay, so when you turn that thing, besides making electricity, producing the electricity, which is an energy, what other energy can you get? Okay, I give you a clue. Look at LED. Besides make electricity to light up your LED or whatever, what else can you get? Look at the LED. I'll give you a clue. Number 5. State 2 advantages of LED as a lighting device compared to filament bulb. Now, why don't we use the normal filament bulb? The normal bulb, the one that we used last time, we use a filament. The electricity goes into a filament and then it makes it so hot it will light up. Okay, that one is the old type of the type of the normal traditional type of bulb. But this LED, you notice you'll see all that in your RBT, right? This is the type of, we call light emitting diode. So this technology of producing the light is different from your filament bulb. Now, why we are encouraged to use LED and not the filament bulb? What is the advantage of LED? Okay, I think you learned that in RBT. I'm very sure of that. Okay, you learn it. Why we use this LED besides, or you can also Google up, all right, the advantages of LED, okay, compared to a filament bulb, the normal, the traditional, the bulb where you have the filament inside there. So 2 advantages, all right. Okay, so I give you, maybe I can start with number 1 already, I think. I can see some of you have answers already. Very good. Okay, let me check up. Stationary, light LED, not a light up. Okay. Right, good. That is the correct answer. So LED put here, up. So here does not, because you didn't cut the magnetic field lines, isn't it? When it's stationary, it doesn't move. It doesn't move where it got cut down. It doesn't cut the magnetic field lines. Okay, rotating LED up. Okay, not lighten. Lighten actually has a different meaning. Lighten means it become lighter. That means it can float. Lighter. Lighten means it is a bit lighter, not so heavy. The meaning is not so heavy like that. So you say lights up. So here lights up. LED lights up. Or you can say it's lighted, it's lit. Okay, let's look at some answers here. Number 1A, when the coil of wire and magnet are stationary, the magnetic field lines are cut. All right, correct. This is false. You're not even cutting the magnetic field lines, right? Both are not moving. Where can cut? Number B, when the coil of the wires move inside stationary magnet, the magnetic fields are cut. So when you move, it cut out. All right, true. Yes, correct. Number 3, current will only be induced when the magnetic field lines are cut. This is also true. Okay, so this is a very important concept that you need to remember. Okay, next. Question number 2. How about question number 2? Induced current is detected. How is induced current when galvanometer pointer deflects? Yes, okay. But in this experiment, you don't have galvanometer, correct? And look at the question, in this activity, in this activity, we didn't connect a galvanometer. So not so correct lah. The concept is correct. Yes, concept is correct. You have a galvanometer point deflect, and that shows there's electricity. But here, not so correct because there's no galvanometer. So what can we see from there to know that the induced current is produced? Okay, what do we see? How do we know got current? It's detected by, okay, which causes it to light up. Detected by the LED, which lights up. Okay, if there's the galvanometer, is correct. Detected by galvanometer. Okay, detected by LED, which lights up. Okay, so it's more correct lah. If you have LED, then you can say, if you really have a galvanometer, you can say galvanometer. Okay, number 3 then. Induced current is produced when what are cut? Okay, when what are cut? Okay, induced current is detected when, the induced current is detected when the LED lights up. Correct, all right? Better lah. But for this one is not wrong actually, right? But the only thing is because experiments, some people will argue, say, no galvanometer, how you put galvanometer there? It's not so correct, right? But if there's galvanometer, this is definitely can be used. Okay, what about the next question? Question 3. Okay, what about question 3? I just need the term on it. Induced current is produced when what are cut? What do you need to cut when you want to produce your induced current? Okay, yes, Gatong, correct. Magnetic field lines. So, magnetic field lines. This is what is needed. Okay, magnetic field lines. You need this word, right? This term. Next one. What and what energy? One and one energy. Magnetic field, you must put, Chloe, you must put lines. Magnetic field, must put lines. Magnetic field lines. Okay, not just magnetic field. Better to say lines. Wrong, magnetic field are cut. Can also actually. Okay, what about 4? 2 forms of energy energy produced in this activity. So in this activity, you can look at the picture here. Besides, when we turn this axle, you're making electricity. But, this is produced by the LED. The LED produces what energy? Okay, I got the answer here. Light, definitely light. Yes, because it is a lighting device. So you will have light. Correct, light. Okay, what else? You will have heat. Yes, heat. Okay, heat and light, they always go together. When you have a lighting device, usually heat and light answer. Now, here, this one is my previous class. I already give you answer here. 2 advantages of LED. I forgot to delete. So here are your answers actually. Now, light and heat will be produced whenever you have a lighting system. But the advantages of LED is it produces more light than heat. So heat is undesirable. Heat is an undesirable, something that you don't want. Because when you want to buy a bulb, we want the light, isn't it? We do not want the heat, correct or not? We're not looking for a radiator. If you want to heat, we buy a radiator to radiate your house so that it's warm. But when we want to buy the bulb, we want to buy a bulb for lighting, it's usually we want to make it bright, isn't it? So what is good about this one? Now I'm talking about C here, energy efficiency. LED is more efficient in terms of energy because what it means is it converts electricity into light and heat. But you have more light to heat. Heat is very little. The energy that being converted into heat is actually very little. So it won't be very hot. The good thing is more of the energy is used to make the light. That means it's very bright. You use a little bit of electricity, the lighting can be very bright. So it's very efficient. We do not want the heat. If it's something that is not, that means very little light but a lot of heat. Like the filament bulb, the filament bulb is quite hot one, you know. You notice when you use the normal, what do you call, keep the answers coming in, see all more the answers. When you have bulb, you find hot. It produces a lot of heat, but the lighting is not that comparable, not that much. So it makes what you call it more heat than light. Okay, so when it's not something is more efficient, it's that you get a lot of light but very little heat. This is what you want from a bulb. We light. We do not want. We are not talking about radiator. Radiator, of course, you want heat lah. We do not want the light. So these things is important now. We need to know that LED is more efficient. It converts more of the electricity into light, not into heat. So it's not going to be very hot. Now, other advantages, long lifespan. Yes, LED can last a long time. That means it's more, maybe you buy LED, it could be more expensive than a normal bulb, but it can last 20, 30 years. Okay, it doesn't really. Okay, but compared to a normal filament bulb, the filament will burn out. The filament burns out, maybe you use it for only 5 years. Okay, but for the LED lights, you can use it for more than 10 years. So in the long run, it's fine. Okay, now let's save electricity. This is one of the advantages. LED, when you use a little bit of current, you can produce very brightly. But if you use the same amount of current on the bulb, it will be less bright because more of the energy is converted into heat. That is the disadvantage. Okay, now I see more answers here. Good. All right. Then directional lighting. Okay, that means you can direct the light with it. All right. Increase energy efficiency. Yes, that's a C one. When you want more efficient, that means it produces more electricity is being turned into light. But your heat is very little only because you don't want heat, right? You want the light. Okay, low voltage operation. Yes, correct. Voltage, you do have higher voltage to operate your bulb. Okay, let's say for example, I give you a simple. The LED light, you use say 5 volts. Okay, not voltage. Okay, low voltage is called watt. I'm talking about watt. What is actually power? And we compare a normal bulb, the filament bulb. All right. Now let's say 5 volts. It produces this kind of brightness. Okay, this kind of brightness like this. Okay. In order for you to produce the same brightness for your bulb, you may need to use more power. Let's say 18 watts. Okay, you see, you use more power to produce the same brightness. This is 它的亮度. So you see, it will be saving more energy because you use less power, you use less electricity to produce the brightness. Okay, so that's what it means by efficient, and also it is power saving. Yeah, okay, low voltage operation, low radiated heat is correct. So this is cooler. When you touch the bulb, you don't get so much heat. But this the bulb will be hot because a lot of the energy of the electricity is produced into making heat you do not want. Important performance, yes. It's more environmental friendly because you don't throwing your filament bulb. Throw. You can't recycle it. For LED lasts a long time, you do not need to buy so many of the LED. to replace your spoiled one. Long lasting is correct. So all these are the advantages of LED. So now actually we are moving more on to K-BAT questions. So we have all these questions that will help you to differentiate between a student and a B student. Yeah. So I encourage you to go and read up and watch documentaries instead of watching entertainment dramas, Korean drama or K-pop or whatever, all these music videos and so on. Spend more time on all this because a lot of questions are now going towards K-BAT, things that you cannot textbook, things that you cannot just read. You cannot expect to get A by just memorizing all the facts in the textbook. There will be questions on K-BAT. That's why we're going to do that. Remember to give you a checkpoint one. So we're going to check answers after that. That's I hope you have all done your checkpoint one. Okay, all these questions in the checkpoint one, checkpoint two, and so on. Everything is going to be checkpoint. They have a lot of K-BAT questions. Okay, so if you are able to do it well, okay, congratulations. That means you're on your way to getting good grades in your science because all the questions are going into that area now. Okay, K-BAT questions. Okay, so far this is what I want to cover. So remember, for a summary, in order to produce induced electricity, make sure you know what you need to do. You need to have strong magnets, need to have wire, the coil will be better, and you need to make the wire cut the magnetic field inside the magnet, in between the magnet there. And once you cut it, you will be able to produce electricity. How to detect electricity? You can use LED light or a lamp, or you can use a that will be more desirable because you can, if electricity, you can still detect. Okay, so that is a lesson for today. All right, you can long lasting, but correct. All these are correct. The answers you Google up. Okay, so I will stop sharing. All right, my screen here, and we will go to your Google Meet, and then we will discuss questions. All right. Okay. So I will see you afterwards. All right. Give me 2 minutes to set up the Google Meet. All right. Bye bye. I hope to see you in my next lesson. All right. Bye bye.